All right, this is going to be the first of many AP instructional videos we're going to do. We're going to go through and talk about solubility rules so you guys get a little bit of a feel for it and see walking into class. Something you covered a little bit last year, but we're going to cover it a little bit more depth because it's AP chemistry. It'll be the same thing for all year long. All right, solubility rules are a set of rules that we apply to determine whether or not an ionic compound is soluble or not. And soluble means it'll dissolve in water, basically. So what are you looking for? Well, ionic compound is a metal and a nonmetal. Knowing the rules, the way you learn the rules is by memorization only. You apply them, and then based on the rules, you'll determine if something is soluble or not, and then we use it in our equation writing. So I emailed you with the link to this video a solubility rule sheet. You would print that out, use it. I would actually have it, follow along as I go through this, highlight it, mark whatever you want to do. That way you're familiar with it, and then maybe make some study cards or some way of learning it. First thing, ionic compounds that have salts of ammonium. If it contains NH4 or any group 1A metal are always soluble. So those, especially the rules are applied in order, but that's the first rule and the one you should know that apply the easiest. If it has NH4 somewhere in the formula or a group 1 metal, it's always soluble. Okay? Next one. Second one is, second rule applies to their similar, anything that has a chloride in here, a bromine, or an iodine in there is always soluble. So if it has Br, Cl, or I in the formula, it's always soluble, but the key in chemistry is the exceptions. See how it says except? Ag, Hg, and Pb. I call those the three gangsters. Ag, Pb, and Hg will be the ones that when you combine them with either iodine, bromine, or chlorine, we consider to be insoluble. So you want to highlight the insoluble component of it. Most of the time when they're testing you on solubility rules, they're going to be testing you on what is insoluble. So a key thing is if it contains Cl, Br, or I, you have to look for the three gangsters, because if it has any of those three, then it's going to be insoluble. Next rule, chlorates, nitrates, and acetates. If it contains CO3, NO3, or acetate, it's always soluble. Always, like rule number 1. It's always soluble. So if that's the case, you know rule number 1, you know rule number 3, automatically makes it easy to determine. Rule number 4, sulfates. Sulfates are always soluble, except we get to the exceptions again. If you look right here, these are the exceptions. So those are the exceptions that you have to learn. So it's CaSO4, SrSO4, BaSO4, and then the three gangsters, Ag, Pb, and Hg as well. The way I remember calcium, strontium, and barium is CBS, like the network. This is Ca, Ba, Sr. CBS is the other three that are insoluble. That with the sulfate automatically is insoluble, which means it will not dissolve in water. Next one. 5, 6, 7, and 8. All of these deal with things that are insoluble. So if it contains phosphate, PO4, oxide, hydroxide, or sulfide, they are all insoluble except using rule 1, which is the first rule that we learned. If it has a group 1 metal or a ammonium, it's always soluble. Oh, I forgot the carbonate right there. You see carbonate right there. So this set of rules you can kind of all lump together. OH, O, PO4, CO3, and S are all lumped together, and then just remember rule 1. What are we doing when we're talking about things being insoluble versus soluble? PbNO3. Why is that soluble? Because the rule says nitrates, rule number 3, nitrates are always soluble. So if you put PbNO3 in water, parentheses 2, you end up with this. You end up with a whole bunch of ions in one beaker. Ki. Why is this soluble? Because K is a group 1 metal. If you look on the periodic table, it's a group 1 metal, so it's always soluble. You put that in a beaker, the ions, if you notice, the ions are broken up. But what we do in chemistry is we mix ionic compounds together. This is an ionic compound because it has a metal here. This is an ionic compound because it has a metal there. I combine the two, and we have to figure out whether or not a precipitate forms. Whenever you combine ionic compounds, what happens is the cations switch places. So the ions switch places. So the metal here, Pb, is going to go with I. K is going to go with NO3. So basically what's going to happen is they're going to switch. You're going to end up with K, NO3, and Pb. The charge on this is 2 plus. Charge on I is -1. PBI. Using the solubility rules, you have to determine which one is insoluble, if any. Sometimes none of them are. In AP reaction writing, something's always going to be insoluble. You know that if it has K or NO3, it's always soluble. So this is not the precipitate. Soluble. PBI. Remember the rule for I? All the I ones are soluble. Iodides are soluble except the 3 gangsters. And Pb is one of the 3 gangsters. So we say this is a precipitate. We show that by writing an S for solid. Because what happens is a solid forms in a liquid. That's what we write and sinks to the bottom of the beaker. That's what it looks like. So apply the rules. Put pause on the video. I want you to really quickly, using the rules, determine whether or not it's soluble or not. And we'll go through or precipitate forms. So you go through, do these, and then hit play again, and I'll go over the answers. First one is soluble. Soluble, which means it's going to be aqueous in solution. That's how we write it. Why? Because anytime you have K, it's a group 1. It's rule number 1. Always soluble. So K2SO4 would be aqueous. The ions would be broken apart. Number 2 is aqueous in solution. Why? Anything that contains NO3 is always soluble. Number 3, PbSO4. Well, the rule for sulfates is all sulfates are insoluble except for 6. Is Pb one of the 6? Yes, it's one of the 3 gangsters if you look on your sheet. PbSO4 we say is insoluble, but we show it as a solid, meaning a little S in chemistry. So we put a little parentheses, a little S subscript. AgCl, soluble or insoluble. If you look at your rule sheet, rule number 2, all chlorides are soluble except if it contains one of the 3 gangsters. That's one of the 3 gangsters, so I'm going to put a little S there. Finally, rule number 5. Well, right away I spot the NH4, knowing that rule number 1, you apply them in order. All ammoniums are soluble, so it's going to be aqueous, meaning it's going to dissolve in a liquid and break apart. When we go to write reaction writing for AP, you're going to notice the key to look for, it's a mixture of 2 salt solutions. It's the summertime, so I'm only giving you one type of reaction, so that's the only one that you're going to be doing for homework as a lead up to August 20th. But keep in mind that that's the key to identifying the problem. You have to predict which salt's going to precipitate using the solubility rules. That's what you're going to have to memorize. The way you do this is you're going to write only the ions that make up the precipitate on the left, the precipitate actually shown together on the right. And then the last thing is in AP, we always want to balance both sides, word. So let's take a look at one of them. For example, solutions of calcium nitrate and sodium sulfate are mixed. Well, if you write it out, calcium nitrate looks like this, and sodium sulfate looks like this. What's going to happen is you're going to switch places. So when you're switching places, the sodium is going to go with the nitrate, calcium is going to go with the sulfate. You have to figure out one of them is going to be insoluble. In AP, one of them has to be insoluble. Well, when I look at this, I know anything that contains a nitrate, the new one, sodium nitrate, is always going to be soluble, and if it has sodium, it's always going to be soluble. So I know the sodium and the nitrate are always soluble. That leaves me with Ca, which is 2 plus, charged from the periodic table, SO4, 2 minus. So how do I write out a net ionic equation? I write the 2 ions on the left and the precipitate on the right. If you want to get fancy, put the little S there and then balance. Next one, silver nitrate. Silver nitrate is AgNO3. Potassium nitrate is Ki. If you look, you're going to switch places. So what's going to happen is K is going to go with NO3. Ag is going to go with I. Well, KNO3, this should be pretty simple. Anything with K is always going to be soluble. Anything with NO3 is always soluble. So I cancel those out. So basically, I'm going to make a precipitate with Ag, which is a charge of +1, and I from the periodic table, which is charge of -1. That is my net ionic reaction. Notice the precipitate is shown on the right-hand side. The ions with the charges are shown on the left. Last sample here, lead 2 nitrate. What's that going to look like? Lead's going to be Pb parentheses NO3 2 tripotassium phosphate. We don't write it like that anymore. We just say it's K3PO4. The K is going to go over here. The Pb is going to go with this one. KNO3, always soluble. PbPO4, not so much. All the phosphates are insoluble except with group 1. When you go to do this, you're going to write out Pb. They already told you it was +2 from the Roman numeral. You should have learned that last year. Plus PO4 3-, and then you got to put them together using crisscross. The ratio is going to be Pb3, PO4, 2, and then you got to balance it by putting a 3 there and a 2 there. And so you look, the sheet you have, we'll do the first one. Potassium phosphate and calcium acetate. What's going to happen? Potassium is going to go with acetate. Calcium is going to go with phosphate. I'll tell you right now, you can almost cancel the always soluble. Potassium's always soluble. Acetate's always soluble. So really what you're going to be left with when you mix those compounds is calcium phosphate. Well, calcium, knowing on the periodic table the symbol's Ca, the charge is 2+. Phosphate is one of the polyatomic ions you were supposed to memorize. PO4 3-, arrow. I go to do it. I'm going to go Ca2, parentheses, Ca3, PO4, 2, and then I go to balance it with a 3 and a 2. I can write an S here if I wanted to get fancy. And that is how you do it. Notice what you see. On the right-hand side has to be a compound. There are no plus or minus charges ever on the right-hand side. Ions are on the left-hand side. If they are soluble, always, you never write them on the left or the right. That's why we call it a net ionic reaction. So what I want you to do this week is A, learn the solubility rules. B, finish the sheet, get it complete. You have 1 or 2 more assignments this week, and if you haven't been studying your polyatomic ions, you want to make sure you get those done because it's going to be important. We're starting off class the first day with the polyatomic ion quiz. You guys have a great rest of your summer. I look forward to seeing you, meeting you, and I will see you soon. Bye.